Hi there, this is Dr. Conrad, and this is the second of my videos on data visualization. This time we talk about Matplotlib in looking at comparison of data and bringing in a CSV file. And this is where I think it gets really exciting to start using Python in a very pertinent way. So let's just start by going through a piece of code and explaining what it does. This is a piece of code that is taken from our textbook, so I'll explain every line as I discuss it. And this particular piece of code will be useful because I'm looking to give you a CSV file that has to do with volcanic activity and looking for you to be able to take the data from that file and create a visualization that is meaningful. So with that being said, let's begin. I'm going to share my screen right now. And I always have a ton of stuff here. Okay, get rid of all these things. And once again, I'm going to be using Colab simply because I find Colab to be very useful and easy to use for this instance. Now, a couple of things to point out with using Colab. I'm going to be importing a couple of CSV files. In order to have these CSV files available to be used on Colab, I actually have to load these files into my Colab library. To do that, I've already done that here. You see my sample data here. But to do that, what I would do is I would click on this particular upload, and I would, wherever my file is, if I had it here on my desktop, I don't have one really on my desktop right now, but if I had one here, I would find it and then I would just upload it. So I have uploaded this already. Now, a couple of things to note. Just because you upload it once doesn't mean it stays there. Google Colab has a process where every couple of days it goes and it purges all of these files that people load. So you have to continually load it when you're going to be using it to create your project. Now, for many of our projects, this will be just fine to use Google Colab because we're just actually practicing. But for the project that I'm going to be asking you to hand in, you're going to need to be able to give me your CSV file so that when I'm testing your Google Colab, I can load the CSV file in, since there's a good chance that Google Colab will have deleted it. So I hope that makes sense to you. So first things first, you have to load your files in the CSV format. And the CSV format, which you already know, is going to have whatever the name of it is. Remember, file names do not have spaces in them. They have to be contiguous like this. So Death Valley 2018 full .csv, okay? .csv, all right? So that's the first thing. So when we start our code, the first thing that we're going to do is we're going to import CSV. CSV is actually a function, and it is from the standard library, and it parses the lines in a CSV file. So that's the first thing. The next thing we're going to be taking is we're going to, from date time, so from a library called date time, we're going to import date time. So there's a library called date time, and in date time, there is a specific module called date time. And we're going to need that particular module because we're going to do some manipulation with dates and times. All right, so that's then from Matplotlib, another library. So here we have now two libraries that are involved in this, datetime and Matplotlib. Now we've already used Matplotlib in our simple exercise of just doing a simple graph, but now we're going to use it again in a little more sophisticated fashion. And we're going to import pyplot, which we talked about before, and we're calling it plot again. All right, so these are so from this particular segment of my conversation with you, it's uploading the files that are going to be used, making sure they're in the proper format, importing CSV, which is a function that will parse the files, importing date time library, and importing, making sure that we have datetime and Matplotlib, that we've used that pip to make sure that they're there. If you're using Google Colab, they're already there. You don't have to do anything, they're already there. But if you're using PyCharm or some other Sublime, you have to do that pip to import the libraries into your resident environment, if that makes, hopefully that makes sense. But we're using this virtual machine. We do Google Colab. We don't have to worry about that. So, but within these libraries, we're using datetime from the library datetime and pyplot from Matplotlib. Okay, now, the first thing we're going to note is that we have to identify our file name. Okay, so our file name here is going to be Death Valley simple.csv. So if you were to just copy this code from the internet, it's not going to work because it's going to say something like data / Death Valley 2018 CSV. Well, we do not have this in a directory called data. If we did that, if we had it in a directory, then we would have to identify that that's where it's coming from. But from my instance here, I don't have these in any specific directories, okay? So my file name is just going to be Death Valley 2018. And once again, I'm just going to make sure that I am recording. Nope, I am. All right, so that's the next important thing. Now, with, you're going to see here, this Death Valley, I just call it file name. All right. So, and now I say with open. So open is a command that hopefully you learned last time in your first Python class. Open will open the file, but it will also close it. So with open file name, which is Death Valley 2018, I'm just going to call it F because I don't want to type all that. All right. All right. So that's the first thing, opening the file and giving it a much shorter name. Now the next line here says reader equals csv.readerf. Well, we know that F stands for file, and CSV reader is a function that will read our file. And we're reading our file and we are storing it in an object. And with this object, we are calling reader. Okay, so this is a name that we just created, reader. We could have called it anything, but in this instance, we call it reader. And then the next line is this header row equal next reader. Well, the next function will return the next line. Now we only have to use this next function once, and it's for really reading the header. And we store it in the variable header row. So header row is where we have the header information from our file. So if we were to look at our file, our CSV file here, we would see that there is a header row and there is then all the data that goes with it. All right. Now, this next line here is a comment. This is how we always do comments. It's just a number sign. And it's just saying we're going to get temperatures, dates, high and low temperatures from this file. So what's happening here? So these square brackets should be an indication to you of empty lists. And we have one empty list, two empty lists, three empty lists. And one empty list is for dates, one empty list is for highs, and one empty list is for lows. So as we're reading our data, each row within our CSV file, we're going to be creating a list. And within each list, it's going to correspond that there'll be one item for each of these items, high, low, and date, so that they can correspond when we're going to be doing the manipulation. So that's what's happening here. We are now creating three empty lists and we call them dates, highs, and lows. So we come here to our for loop, and we know that a for loop is something that it's going to do it until we're at the end of the file, or if there's some condition that's met. So we say for the row in reader, and reader we've already defined as the object of from our file, all the data we've moved to this object reader. For the row in reader, and we've taken out the header. So we've removed the header and we just have our data. We're going to say here, current date equals our date time strip row 2 with this y percent y, m, and d. Okay, there's a lot going on in this particular thing. So this is a method here, strip time, of which we're taking the time off of the date. So the time is stripped from the date. And what is happening here, and it's starting with row 2 here, is it's saying go, and that it's going to identify where this is going to happen. So it's saying it starts, there's the year it starts, and notice that this y here, this percentage means that it will take everything up until the year, okay, up until the next dash. Because see, here's we're identifying the format, and we're saying this is the year, then there's going to be something, a month, and then there's going to be a dash. So the dash is going to be the differentiating between year, month, and day. And this percentage says everything up into this dash. Now, I want to point out to you that for this particular process, you need to have this Y capitalized. The M and the D don't get capitalized, but if you do not capitalize the Y here, it will not run. Okay, so here we're going to take away all of the times that would have been in our file, because in our file, we actually have times associated with each of the dates. And we don't really care about all those times. We just want the date itself, because we're going to graph it by date and not put the time on it. So we just don't even want that. All right, now here is something that might be new to you. It says try. And what that means is, okay, for the row and readers, look at it, try it out, and see if there is something in the row 4. Now, how do I know that the high is in row 4? Let's just take a little walk back here. So here is my, let's see. Yeah, I think this is it. All right. Here is my file. All right. And let me just, okay, here is my code here. And what I did here is I added this extra piece here. This is just looking at the header, and then the reading, creating our object, and then moving past the header. But I want to know what is the index for each of the data elements within my CSV file. So I see that within this file, if I was to look at this file, the very first one is station. The second data element in this file is name. The third is date. But if you remember, indexes start with a 0. So we want date, which is 2, and we want the maximum, which is 4, and the minimum, that's 5. So that's how I identify what index goes with which item. So here I say for my date, which was 2, and if you look back at here at this particular file, date has the index of 2, and now maximum has the index of 4. So we should be able to come back here. High is going to be 4, and low is going to be index 5. All right. So if you're not sure which index something is, you can do some simple little Python code just like this, that for index in the column header, enumerate, print the index in the column header, and you get all of what you need to do. So I think this is a really effective way to do this. Okay, so we say try it, and if there's something there, then we're going to take that, we're going to append the date, and we're going to append the high to the high list and the low to the low list. So we append to the date, we append to the high, and we append to the low. So that's how we would then we would create our information here. Now, if, however, we have a situation where there is nothing in one of these data fields, well, then we don't even want it in our graph, right? Because that's an invalid field. We just want to print it out to see, because we want to see how many of them would fall into that category. You're going to be running this on, thousands of rows of data. So you're not going to be doing a scan to see what's there. You're going to be, letting the computer do the hard work. So that would be what we would do. So what this does now is it goes through every row in this CSV file, which is actually an object that we've created. It goes through every row. It puts the current date and into the current date list. And it then puts the high in the high list and the low in the low list. All right, so you can see that that's a very, very helpful here in moving this along. All right, and the names of our lists, as we have, our dates, highs, and lows, and we are moving them into this particular field. All right, now we come into something that we know. So now we're going to start to plot it. We've got our data together, and now we're ready to show what we have. So, because we've created our 3 lists, right? With the date, the high, and the low. All right. So if I wanted to, I could, just to show you, I made this a comment, but you'll see why, because there's a lot of data. If I wanted to print my current date, high and low, to see what do I have, you see that here I have my current date. Here's the time being zeroed out. Here's my high, and here's my low. Okay, and I have a lot of data here, so we're just gonna kind of exit out so we can start it again. Okay, so let's continue. So that's what we've created by having it go through the loop and take the current date, the high, and the low, and put it together. Now we're ready to actually plot it. So from our last video, we saw that we have this Seaborn, and it's a style. And there's several different styles you can use. It just has a lot of built-in functionality. There's something called dark Seaborn, light Seaborn. We're just going to use Seaborn. The chapter goes through it. You can also look online to get other variations of what this style could look like. But we're going to use Seaborn. So that's just a style that we're using. It's a method style. And if you recall from the last time, we had our figure. So we have this fig ax equal plot dot subplot. What does that mean again? Well, fig represents the entire figure that's going to be created. Ax is equal to a single plot in that figure. And that single plot will be created by our method here, plot.subplots. Okay, so that's that. If you remember, that was part of what we talked about in the first video. It is one of the methods within pyplot. All right. So that's where that comes from. It comes from that library. Okay. And then here we have here our AX plots is going to have the date with the highs. So it's going to for the highs, it's going to make the highs a color of red. And this is just the alpha, just talks about the intensity of what that would mean. So it might be useful to see what this looks like. So let's just, okay, I want to put this back as a comment so we don't have that go again. Boom. Okay, so I'm going to just run this quickly. Voila. Okay, so if we look at this, we can see a couple of things here. So Seaborn is this style, and we see that we have the figure, which is the whole figure here, and the plots. So each of these are plots, an X and a Y, and the highs are red. So here we have the red ones here. And if I change this alpha, let's say I change it to, a 1, for example. This is the intensity of that color, I believe. Run it. And you see it's a much more bright color here, the red. So this alpha just tells you what is the intensity of the color red that you're going to be using. I mean, if I change this to a different color, it'll be a different color. Okay. And then here we have the lows. So it's for the date. So there it's going to, we know that the date will be, the same date for a high and a low, because this particular graph is charting the difference between the high and the low for a given day. So that's what makes this one pretty cool. It's a daily high and low temperature. So here we have the lows. And then this color here that's filled in between the highs and the lows is called this face color. And, the alpha I talked about before, but it's going to, go from, it's going to, fill in this entire area for the entire graph between dates, highs and lows. Okay, so if we just did highs and lows, it might not do it between dates, right? So, so you have to say, to get this smooth color, we have to have it be between dates, between this date and this date and this date and this date, and highs and lows. So that's how we get this kind of full shading. Otherwise, it would be a little strange. So, and you can play with this to check it out yourself. All right. So that gives us our graph. And now we want to make it meaningful so anybody who looks at it can see. So the first thing I want to show you here is, while we're looking at it, is here we have a note, missing data for 2018 to from February 18th, 2018. And remember, this is produced because there must have been a value here when it went through the try, instead of it just total bombing. That's why we use try. Try will just allow it to keep rolling even if there's a problem. So if it runs into a problem, we say, okay, if there's a value error, and that's how we handle value errors. Value error is a function. If there is, then we're going to print this, and we're printing just the current date. Okay, so that's where this comes from. But now here we're going to format our graph here. So we start with a title, pretty simple, daily high and low, 2018. We have this /n, means start date, go to a new line and put Death Valley, California. And then, here's where we're saying our title, our plot title is going to be font size 20. If I wanted it bigger, I could change it to 40, just to show you. Okay, now it's bigger. Okay. And then we have our X label. All right, so our X label is going to be over here. and our font size is going to be, we're not putting any type of label with it, so we leave it blank because the actual dates itself speak for itself. Okay, and as you notice here, we have this Fig auto format X date, and what this does is it's figure auto format. It creates the date so that it's a diagonal, so they don't overlap. That's what auto format. It's a method. So these are just methods that you could look into to see how you would make your graph the way you want it to look. This is one, but I think it's very effective for being able to put the date so that you can still get the information without having to have it crammed together or having it overlap. Okay. And then here's the temperature here, temperature in Fahrenheit, the font size, pretty easy. And then these, the ticks, major, the label size is 16. If we made them bigger, just for the heck of it, I think I did this last time. You know, it just makes these particular graph boxes a little bigger. So we'll just go back to what it was before, which I think was 14. Always something. But the important thing is here, this plot show, because without doing this plot show, you wouldn't get any type of figure. So one interesting thing about this is that you can take this. Now, it appears that in Colab, I don't see how, it doesn't come with some of the affordances of being able to take this particular graph and download it. But on most other editors, there will be some type of menu on the bottom that will allow you to do that. So make sure you try to do it with that. So that concludes going through the Death Valley highs and lows. Hopefully I have explained what each of the lines of code are doing, and you should practice it yourself. The assignment is going to look at volcanic activity and do some similar types of work here. So until then, if you have any questions, you know how to get a hold of me. Thanks and have a great day.